Hi, so today I'll be teaching you how to look for the mean of a normal distribution from direct integration. We know that the f of x of a normal distribution is 1 all over sigma square root of 2 pi e raised to power minus half x minus mu all over sigma square, where x is going from minus infinity and mu is going from minus infinity to infinity, while sigma square is greater than 0. So this is the f of s of a normal distribution. For us to solve this, we have to take note of something. We have to take note of the standard normal. The f of x of a standard normal is 1 all over square root of 2 pi e raised to power minus half x squared. So this is the f of x of a standard normal. And for the standard normal, expected value of x is 0, variance of x is 1. And the expected value of x is written like this: minus infinity, infinity, x, 1 all over square root of 2 pi e raised to power minus x squared all over 2 dx. So whenever I have an integral like this, I can equate it to 0 because it follows a standard normal distribution with mean 0 and variance 1. So you have to know this before we start solving for the mean of a normal distribution. So back to the mean of the normal distribution. So the mean of a normal distribution from direct integration. So we know that expected value of x is integral minus infinity to infinity x times f of x dx, which is equal to integral from minus infinity to infinity x times what is f of x, 1 all over sigma square root of 2 pi e raised to power minus half x minus mu over sigma square dx. So this will give us 1 all over sigma square root of 2 pi. As I'm taking the constant outside to simplify my integration. So I have 1 minus half x minus mu all over sigma square dx. To simplify this further, I can make the function inside the bracket, which is x minus mu over sigma, to be equal to a letter k. So from this, x minus mu, if I cross multiply, I will have sigma k. X will be sigma k plus mu. If I differentiate, I will have the x will be sigma dk plus 0. When you differentiate mu, you get 0. Let me call this equation star for asterisk. So substituting into equation star, I will have 1 all over sigma square root of 2 pi minus infinity to infinity. So what is x? What is x? Look at x. X is sigma k plus mu e minus half. So what is x minus mu divided by sigma? That's all k, then raised to power 2. What is the x? Look at the x. The x is sigma dk. We are making progress. If I want to simplify this further, I can expand the bracket. If I want to expand the bracket, I will have integral minus infinity to infinity sigma k times e raised to power. Oh, first I have to cancel this by this. So this will cancel out. So I have e minus k squared over 2 plus all over square root of then dk 1 all over square root of 2 pi minus infinity to infinity mu times e raised to power minus half k square dk. Take a look at this. It looks like the mean of the standard normal distribution. It looks like the mean of the standard normal distribution. Let me show you about that. Let me simplify it further so you know that it looks like the mean of the standard normal. If I take sigma outside, I will have sigma integral minus infinity to infinity 1 all over square root of 2 pi e raised to power. Then I will have k here minus k square all over 2 dk. This is equal to sigma times expected value of k of a standard normal distribution. And the expected value of k, that's k follows a normal distribution with mean 0 and 1. The mean of a standard normal distribution is 0. So this becomes sigma times 0, which is 0. So this means that this is 0. So back to the second part. We have 0 plus 1 all over square root of 2 pi. So let me call this is 2 asterisk. So I'm continuing from 2 asterisk. Integral minus infinity to infinity mu times e raised to power minus half k square dk. If I take my mu outside, I will have mu minus infinity to infinity 1 all over square root of 2 pi e raised to power minus k square all over 2 dk. This looks like the f of x of a standard normal distribution, and the integral of the f of s of a standard normal distribution will give you 1. We are minus infinity to infinity 1 all over square root of 2 pi e minus k square all over 2 dk is 1. So if this is 1, so this becomes, so my second asterisk becomes mu times 1, which is mu. So therefore, the expected value of x of the normal distribution is mu. Remember the two things I used there. I used that the expected value of a standard normal. So if x follows a standard normal, when we say standard normal, the mean is 0 and variance is 1. If it follows this, then the expected value of x is 0 and the integral of the f of x is 1. So this is what I used to solve it. Though you can also prove this. In my next video, I will show you how to prove. I will show you how to prove that this is equal to 1. I will also make another video to show you why this is equal to 0. Thank you.